Also, I'm happy to present our research on the topic next level electric power intelligence, engineering resilience, and the tactical level. Also, I try to take a look on this issue from different sides of my background because mainly I'm cybersecurity specialist. At the same time, I'm military, and at the same time, I'm a senior scientific researcher in Puchov Institute Modeling and Engineering. Take a look on this. Firstly, when I try to make the research on this topic, I try to find the similarities between my main areas and put them together. And for me, it was interesting how popular this topic in the scientific society, in scientific databases like Google Scholar, Scopus. And I explore for myself that in this area is present some leaders by the countries. These countries is like US, China, and India. And it's okay, but on my screen is everything.
That's good. Yes, it's good.
Okay, now you see the second slide. Yeah. Okay, let's do this. And this things like that we have the leaders in the researchers in this topic is not incidentally, because these three leaders, this is the largest energy consumers in the world. It's important to be successful in the area of energy intelligence if you want to produce the energy, if you want to work with the energy, for sure, yes. Let's try to define what does it mean, the energy intelligence. And on this question, I have a look from the strategical perspective and from the tactical. Because from strategical, we usually associate this term with how to find the energy resources, how they evaluate the energy resources. And usually in the internet, it's easy to find the different kind of the reports on the topic. But at the same time, what does it mean energy intelligence on the tactical level? And here we should thinking about analyzing information about energy resources using and distribution policy technologies in a specific region, country, maybe the part of the city or the separate building. And understanding this needed to know that could be different types of the energy intelligence: governmental energy intelligence, military energy intelligence, business energy intelligence, scientific and research energy intelligence, and international energy intelligence. This is the kind of classification of energy intelligence which could be. And in the times of a war in Ukraine, and when we have the huge issues with electricity because of cyber attacks, kinetic attacks from our adversary, we know that the topic of energy intelligence try to have the new interest of this because the front line is moving. Critical infrastructure objects can move too. And previous speakers talk about the mobile reactors. Also, it's have the decision too, because how to make the recognition to deploy these reactors. Or if we are talking about how to move the data center, where is the best place, where is the most security place, where is the most resilient energy infrastructure to deploy this. For these questions could be answered by the energy intelligence on the tactical level. At the same time, military intelligence, it's like more connected to my area as military man. I can say that how to find something which was replaced, how to define the new factory which appear, how to define the movement of parts of the infrastructure. And another question to cybersecurity, how to find the data about this moving. Probably you have heard the phrase when somebody say, "Show me your trash, and I will say something about your life." The same could you show me the results of using the electricity power in the building, and I will try to suggest what is inside this building. It means there presents the opportunity to create some kinds of the profiles of different objects by the values of the using the energy. And for this, present a couple of information collection methods which could give the approaches to achieve this data. For example, simple example for our life. When we have our tickets for each month for the electricity usage, there present some data, how much we have used. Our counters of electricity send this data through the mobile operators to detect company in Ukraine how much we used. We pay for this to the bank, and the prices is transparent. It's possible to calculate by money. For example, how much you paid, you only divide to the price of the 1 kilowatt, and somebody will need how much you have used for this. Also, everything could be founded, and it's not so much hidden. Also, talking closer to the military energy intelligence, we can, as military, define this on the strategical military intelligence, operational military intelligence, and the tactical military energy intelligence. And mostly that's the topic of the research connected to the tactical level. I want to highlight this topic like how to find some object which was hiddenly moved in the city, and how to find the conditions to move the object. And when everything moving fast in the combat area, assessing the impact of enemy attack on the energy infrastructure that directly support military operations. Because to deploy the troops and their equipments, you should find the possibility to deploy them. Also, the great dependency with the digital infrastructure, this now is highly valuable, lose the connections, lose the life. Because of that, the approach of structural identification methods was developed. Its approach proposed the use 8 steps to define the object and its profile. First of all, it's collection of energy consumption data. As I previously mentioned, it's possible to find this data in different ways using different methods of collection information. Evaluate of the energy systems, because some objects could be similar, data center to data center, some power plant to another power plant. Yes, similarities every time is present. At the same time, create the energy profile. Usually, the industry which creates some decision, they have some kind of patterns. And it means that possible to find different objects which built by the pattern. Analysis of the power outage data gives the opportunity to see what was changed. For example, if the data center moved from one city to another, the difference in power gauges will be the same as the profile of the data center has. Modeling and planning, how to predict the possible conditions where to move this, what is the security threats will appear. Evaluate and optimize, maybe use the additional sources of the power. Documentation and monitoring, because it's so important to find the kind of mistakes or lessons learned for the future, and resilience assessment and enhancement. Also, moving to the case study, for example, we can take the simple metro data center. It's like up to 500 servers and facing the energy efficiency to the outage infrastructure. The closest example was in 2022 with the Google company. They have the fire disaster in one of the data center, and some services was not accessible in some regions, and some services became work slower. Also, it's not fully imaginative case, but at the same time, following the methods, let's see what possible to do in different steps. And the first steps, as I said, mentioned before, it's collection the data, but the data should include the average peak consumption and the periods of high load, evaluate the existed power supply system. Sorry. Okay. Also, uh, assess the reliability of the current power sources, including the frequency and duration power outages. Create the detailed energy consumption profile for each zone section of the data center. How much takes the servers, how much takes the cooling system, how much takes the lights and others. Analyze data on the frequency or the duration of outages to identify the possible problems with energy supply. I also create the comprehensive model to simulate the scenarios of data center energy infrastructures. For example, which kind of disruption could be? What can influence on this? Conducting to the simulation various data center relocation scenarios. How better to move the data center? Also present the mobile solutions for the data centers. And these solutions used in Ukraine by now. And the main question when the data center moved, where is the place to connect it? Uh, Going to the end of the method to draw the detailed documentation of each stages, which was appear for the lessons learned and some kind of issues analyzing. And for the next steps, it's a method focusing for assessing the enhancing of resilience of the data center energy infrastructure. The engine of the system can withdraw and quickly recover from the disruptions. Where do the physical damage, cyber attacks, or other external factors? And to conclusion, to develop the approaches of energy intelligence on the tactical level brings some kind of advantage of the real time of monitoring the situation. For security purpose, for us, when we move something, we should understand how protected data about power usage. At the same time, to find something, we should understand where is the best conditions to move. According to these main purposes, I think for the future researchers, it should not stop only on the structural methods of the energy intelligence and start to develop the parametrical methods for energy intelligence on the tactical level. Brings the opportunity to evaluate some kind of metrics of security, deploying the objects, and the opportunities to fastly moving these objects to another place. Also, time is coming over. Thank you for attention, and I would be happy to answer your questions.
Thank you, Andrei, for your presentation. Do you have any question to Andrei? Okay, I have one. When we talk about intelligence energy, and when you determine it term as a collection different type of data, and it means that there is another metrics, another technology, collect this data, analyze this data, and the measurement of this data, and the collect of this data in time, determined by the model traditionally using to analyze this data. And when we collect different type of data in one point, there is the problem of analyze this data to non-contradictions. Yes, that this data must be correlated, and ordinary this data contradiction. When you get the data from task administration, for example, and from central bank, for example, or another institution, you find out that this data different, the same parameters, measurement in different manner in different institutions. What can to do? What can we do with this data? How to solve this problem on
This,
tactical level and on strategic level also?
I thinking it's good to divide my answer on two parts because everything depends mostly who collected this data and the purpose of the data collection. If this data collected by adversary with the purpose to identify our critical infrastructure objects, for example, the producement of the military equipment or drones factory, yeah, which is a secret where they placed in Ukraine. This is one thing. Another one, if it's collected by the government. By the government, it's collected possibly but only on the level by the transactions which people pay through the banks, and banks probably can report to the national bank, but it's difficult to tracking them for sure. Also, the data collected by Ukrainian companies like Yasno and the company DTEC. These two companies, Yasno is a governmental one, DTEC is private. These two companies have the data about how much energy people used, and also for them only to sort the tickets, and they will understand what placed in this building by now and months ago. Yeah, but at the same time, what I worried about that technologies allow us to send the data from our electricity counters from the flats through the mobile operators, not in not encrypted way, to these companies like DTEC and Yasno. At the same time, the mobile operator has this data. And I have not found any requirements for protecting this data on the side of the mobile operators. It's,
Mhm.
it's
It's no. I understand that there is situation when the data can be controlled and the measurement system does not produce any conflict between the data. But in situation with economic processes, for example, trading from the body, export, import, we have get information from central bank, for example, and from task administration. And this information significantly differ in different time period. And what to do with this data? It is not possible to work. It's very difficult problem. Why? Because this data is very expensive to get. It's not simple to get from any information system, from sitting by the in internet or network information network. It's very difficult problem. Why? Because the institution that developed the model of analyze the data, or analyze not data, analyze the system of trading, for example. sitting in central bank and sitting in the tax administration, the purpose of observation of these processes is significant differ. It's a problem. How to build the one point of view on all processes in economy, in information system, in energy, and so on. How to find this one point of view on these different points of these different processes, sorry. It's very, very difficult problem. So it's I don't understand how to solve this intelligent energy, how to collect the data from consumer, from the householders that paid one per month to combine with a payment from business that paying more frequently period, yes, and it's a problem. How to solve it? How to build this energy intelligence? It's not a collect data, it's more serious questions.
This is the governmental approach question, I think, because, for example, I'm talking in my presentation, as you see, about the approaches of open source data collection, or
Okay.
the data which could be assessed by adversary by hacking attack. But to do this in a centralized approach without the governmental regulation, I fully agree it's impossible.
Yes, I agree. Thank you.
Thank you so much.
One more questions, please. No one. So